Hi, everyone. I'm Divya Mohan, a principal technology advocate at SUSA, and this is yet another episode of Rancho Live. As with every episode of Rancho Live or any of the other live streams that we host on the Rancho YouTube channel, we first start off with a set of ground rules to be followed during the live stream. This is primarily because each of these live streams, whether you're tuning into a Rancher live episode or a global online meetup or even one of our masterclasses, each of these is curated to be a learning experience. And for people to come and ask questions of the presenter or the topic guest or whoever is on here. So it is essential that we maintain this as a learning environment and we have fruitful conversations. And in order to aid that atmosphere, we request that during the course of this live stream, if you have any questions or if you have any comments on the kind of content that I and the guest are discussing, please make sure you leave them in the comments section wherever you're tuning in from. I will be monitoring the chat on YouTube, the LinkedIn comment section, the Twitter comment section. I'll be monitoring all of that. So we will be getting to the questions as and when they come up. And Anne, who is our guest for today, has kindly agreed to have them relayed to her in real time, and she's happy for our conversation to be interrupted and for the questions to be asked and answered in real time. So that's the first PSA. And the second PSA is that when we are having these interactions, since this is a learning environment and since we're all here to learn from one another, it's a sincere request to be as courteous and as civil as possible when interacting with the topic expert, who's Anne, of course, for today, and also with other attendees of this live stream. And that's pretty much it. There are no complicated rules, and we really do hope that this is an enjoyable learning experience for all of you. And we hope that you enjoy the conversation today. So, without further ado, I am going to be bringing on my guest for today, Anne Currie. Uh, and thank you so much for joining us today. I've read your book. I mean, I am definitely a fan of all the work that you're doing, but this live stream has been a long time coming. Thank you so much for joining us today.
I'm very happy to be here. Thank you very much for inviting me on.
Yeah, so I am gonna have Anne introduce herself because she has a very, very long list of accomplishments, and I think I would rather have her speak to all of them and have her give you the context of um, where she's coming from and the topic of green software that you're going to touch upon. So Anne, over to you about a bit about yourself, really.
Well, thank you very much. So I've been in the tech industry for over 30 years now as an engineer to start with. And I used to, back in the early 90s, I worked on big C server applications that had to be written in incredibly efficient code on the terrible hardware we had back then. But I've been in the industry all the time since. So as a manager, as an engineer, as a manager, as a startup founder. And latterly, I've been very involved in the green movement, the moving over to how we make our systems run on renewables, which I think is really the fundamental meaning of building green software. And I've written quite a lot of books. I've written the most recently, the O'Reilly book, Building Green Software. I also wrote a book called Cloud Native Attitude, which has just come out in its third edition, which is almost a precursor to building green software, because the principles of cloud native and the principles of green software are very similar. And I'm also a prolific science fiction writer. So I've written 8 novels in the Panopticon series, which is also related to the climate, cli-fi, and solar punk. So it's very nice to be here.
And it's an honor to have you here. And diving straight in, because you've already set the context with your introduction about your specific topic of interest, which is green software. How did this get started? Like, I know because I've read the book, or rather, I've listened to the book.
Ah,
Um, that you started your green software journey by reading the Borg paper by Google. Could you
um,
shed a little more light on this? This is what I heard from the book, by the way. So I'm assuming the sources are correct.
yes. Well, yeah, totally. I was very interested. Well, back in, say, in some way, I've always been interested in code efficiency, because that's where I started my career. How we wrote things like Exchange. I was on the first version of Exchange. How did we write software like that back in the days when there was no bandwidth, the machines were very poor, there was no cloud, there was no, it was all quite inefficient. We used to write very efficient code, written in C, but we also used to really have to concentrate on getting good machine utilization as well. So the machines were not just sitting around barely used, 5% utilization, that kind of thing. And so I was quite interested when containers first came on the scene. I was really interested in the power of containers to bin pack effectively onto machines. How if you use an orchestrator, orchestrating encapsulated tasks inside containers, you could achieve really high machine utilization. And if you can do the same work, you can deliver the same service to your users and customers using fewer machines because you've got higher machine utilization. That is the greenest thing you can do. It's the easiest and safest, greenest thing you can do. And the world's experts in that, certainly the world's experts in the time, were Google, and the way they were doing it internally using their Borg scheduler, which eventually a simplified version of it was published as Kubernetes. But it was there entirely to get up their machine utilization to both save money through machine efficiency, and because they were hyperscalers, and in those days, a hyperscale cloud might have cost literally any amount of money, but they had to get the price down. So they used machine utilization to do that. But also, they had to be incredibly resilient. At hyperscale, things go wrong all the time. So you have to be really resilient to that. And so cloud native approach, the Borg paper, was all about combining machine efficiency and resilience. And actually, green software is based on the same principles. Because they work.
Right. And if we were to talk about and explain it like I'm five definition of green software today, what would you what would you coin it as? What would be your definition of green software? I know that the Green Software Foundation has a definition there, and you have given a lot of it in your book as well. But what would be your specific definition if you were to explain it like someone's five?
Well, I think so. The Green Software Foundation give a really good definition. But I think there is a more of an abstract definition to go on top of that. So the Green Software Foundation give the definition, which I think is absolutely fine. It's a good definition, which is the software that causes the minimum amount of carbon to be emitted into the atmosphere as a result of running your systems. And that's usually a combination of operational efficiency, so using the minimum number of machines to produce the output you want. Code efficiency, right, using the minimum number of CPU cycles, because each CPU cycle requires energy. And finally, carbon awareness, so running more when the sun's shining or the wind's blowing, or less when it isn't. I actually think that nets down into, and this is a bit more of a controversial definition, but it's right. I think it's right, which is that really it's about designing systems that can be aligned with renewable power in the future. So it's about the kind of minimized carbon is a kind of minimize the downside definition. My definition is more about cash in on the upside. So there's a good story. we tend to have a discussion at the moment which says climate change is bad, it's a bad story, but we forget that there's a really good story here as well, which is that renewables are incredibly cheap, so much cheaper than fossil fuel power. It's a dream of humanity to be able to have all that really, really cheap energy to run everything on, but it's not the same as fossil fuel power.
Right.
Fossil fuel power, you pay a lot for the predictability of it. Renewables are cheap but unpredictable. So I would say that nowadays the definition of building green software is building software systems that can run happily as much as possible directly on renewable power without having to put batteries and other storage systems in the mix, because they really make it much more expensive. So green software, to my mind, is software that runs on renewables. And I think it's
Right.
the same definition.
It is. I mean, to a large extent, I would see both of them aligning. But also, like, I think we're getting very specific with like Green Software Foundation as to what like gets it categorized as green software. Like you're just saying that like it's running on renewables, but like I think the Green Software Foundation definition offers like a way to measure it, when you're bringing things in like uh lesser amount of carbon emissions and carbon awareness and stuff like that. I'm not saying that there's a direct correlation, but to me I think that's just quantifying what you just said and putting it into like a metric format so that people are better able to grasp the concept of the benefits that building and developing green software can entail. I think that's the difference for me. I don't think they're like widely different, but this is the difference that I can think of.
Yeah, yes, and certainly the Green Software Foundation is more, and I've been involved with them since the start. I mean, I massively reference what they do in the book, and I love what they're doing. But I think that sometimes we forget why we're doing it.
Yeah.
It's taking it up to an even higher point, because things like if you're running, you can be low carbon if you're running in France on nuclear power. I have no problem with nuclear power. It's absolutely fantastic. But it is very expensive because it is highly, highly predictable. And nuclear power
Right.
is low carbon, it's highly predictable, and it's expensive. I think for me, being green is about how we're going to take advantage of that cheap power that's coming along. And cloud native ties in very well with that. Cloud native is really all about designing a system that is quite responsive and doesn't need that base level of incredible reliability which fossil fuels and nuclear give you, and you pay through the nose for. It's kind of like taking a lot of the stuff that we've learned from cloud native about responding to things that we weren't expecting, changes, and still maintaining. So about maintaining a flat level of service, an acceptable level of service on top of a variable platform, a variable base. So yeah, and so I think that's why I think that cloud native and green software are very aligned, because they're really all about how you get that on top of that.
On top of that variable thing, yeah.
Mm.
And you mentioned, and I think you've also covered a little bit of it in the last few sentences, wherein I think the definition itself has evolved over the years, not just since the evolution of since the conception of software itself, but also as in the last 30 years that you've been part of the industry. So how do you see it having evolved from like the early 90s to what it is today? Like, I do know that hyperscalers and a lot of the other software companies have maybe had like sort of strategies, ESG strategies, centering around bettering their carbon efficiency and thinking about thinking about the environment in general. But have you noticed a shift in the strategies around this from like organizational perspective across the industry?
Oh, absolutely. I mean, there's been a huge difference in the past 30 years. And I would say that difference all focuses around what's your biggest constraint that you have in the industry. So 30 years ago, the biggest constraint we had was, well, actually, we had two giant constraints that we had to push for at once. One was the machines were terrible.
Yeah.
We had so little power, so little. There are at least 1,000 times worse than the machines are now. Probably worse because they're also more unreliable. But we also had bandwidth constraints. I mean, bandwidth. There was no bandwidth 30 years ago. So
True. Yeah.
everything we did was focused around minimizing the number of CPU cycles and minimizing the number of bytes, the bits. And if actually in my old day it was bits, minimizing the number of bits that you transferred across the network in order to provide that service, that minimum level of service that your customers needed. So that was our constraint back then, and we did, and everything had to work towards that constraint, handling that constraint. That was why we wrote stuff in C, and because or even assembly language, because it really helped us to do more with less. But as time has moved on, the constraint has moved away from that. And Moore's law kicked in. Hardware engineers fixed a lot of these problems for us. And suddenly that was no longer our constraint. And the constraint became more like, developers, availability of developers, developer skills, ability to iterate. And it's writing. It's even I wouldn't. Well, these days, no matter what I used to do 30 years ago, I couldn't write in assembly language anymore. I could barely write in C anymore. I would probably use Rust these days, but I probably wouldn't even do that. Everything then became about how we make developers' lives easier. And we used additional CPU cycles to do that. We provided platforms that let you write in much simpler code without necessarily having to think about it quite so much. And we also tried to make code reusable and shareable, and we used into open source. And we said, okay, well, rather than having to write everything yourself from scratch, which we used to have to do, you use this library. And the libraries made the life much easier for engineers by making code quite general, reusable, rather than specialist, which was often much more efficient and faster to run. So we've moved gradually from our constraints being resources to our constraints being developer time and training. And that is the world that we're currently in. And frankly, it still is the world that we're currently in. Although the only thing that might make a difference to that is AI, because it uses so much power. Suddenly everybody's having to think, hang on a minute, we might have to dig out some of those old skills that we had.
And do you think the constraints that you mentioned right now, do those actually contribute to the hesitation or the skepticism that organizations typically have in trying to do the right thing when it comes to environmental impact? Because when you're talking about doing the right thing and lowering your carbon emissions and using better sources of energy, all of what you mentioned right now does play a huge role. Like earlier on, we used to have more inefficient machines, but that was the sign of the times that we lived in, and that was the sign of the progress that we've made thus far. So do you think that also contributed to the way green software has been viewed, the resources and the constraints, and how it has been adopted as a practice over the years? Do you think it has actually affected it?
Yes, very much so. I'm a big believer in that we have to say over and over again that you have to have both. You've got to have green systems and developer productivity. Otherwise, people will still choose developer productivity over carbon reduction. And that means that actually you need to be looking at adopting best practice that also happens to deliver carbon reduction. So I never suggest, I would never suggest that an enterprise looks at rewriting their code in C or Rust in order to reduce their carbon emissions, because they would go out of business if they did it. And a lot of people still see that as being the gold standard of being
Hmm.
green, and it isn't. The gold
Yep.
standard of being green is to work on, if you're an enterprise, to work on your operational efficiency. It's to say, well, hang on a minute, could we realistically be doing this with half the machines? And it quite commonly you can. It's a bit of an investment, but it's nowhere near as big as an investment. Just do an audit of your systems and say, find the machines that are over provisioned and just right size them. Turn off the systems that are still running but are not really used anymore and not really kept patched. And there are lots of knock-on benefits to doing that. Yes, it requires a bit of engineer time, but it'll save you a load of money as well as saving carbon. And those systems that are running but not really doing anything for you anymore, they're the ones that get hacked. So it also produces a more secure system. So yes, you're quite right. You've got to have both. There is no way we can go back to optimizing systems anymore. We moved away from it for a very good reason. We need both. We need to be
Yeah,
able
we
to.
definitely do. Yeah.
But there are options. There are ways that we can get things written in Rust or C, and that are efficient. And that is by requiring our platforms to be doing. Get your vendors to do that work. Don't do that work for yourself. Go to your vendor and say, how efficient is that platform? Because in the long run, if you're running on an inefficient platform, it's going to cost you a lot of money, because it's always going to have to run on fossil fuels. And they're just going to, the difference in price between fossil fuels and renewables is at the moment, it's looking like it's going to be at least tenfold. So, you know.
Yeah. And talking about operational efficiency and how it has to be one of the first steps that organizations take in this journey. um I'm just gonna start off with like the green software maturity matrix, because I know that that is one of the things that organizations can use in helping improve their sustainability quotient, if I may put it that way. I know that it's not the exact term, but I just like referring to it as the sustainability quotient. So could you sort of talk about all the levels in the green software maturity matrix, talk through them in like the ways how it can aid organizations to help improve their initiatives around sustainability?
Yeah, totally. Yes. So the maturity matrix was something that me and my co-authors of Building Green Software, Sarah Sue and Sarah Bergman, came up with, because we kept going, talking at conferences, and people were getting confused about what's the easiest thing, where's the right place for them to start. And a few people suggested a maturity matrix. So a maturity matrix is a project planning tool. They were first invented as a concept by the Carnegie Mellon University in New York in the 80s, so a very long time ago, even before my career started. And the idea of a maturity matrix is it says two things. It says, where are you going? What does good look like? What's the acme of this? And in this case, it's being able to run your systems on 24/7 carbon-free electricity, CFE. So for every watt that's powering your system, there is a matching low carbon watts going into the local grid. And that's nice. It's nice to know where you're going. But I would say, even more importantly than knowing where you're going, a maturity matrix, which is a matrix, but I sometimes like to see it as a pyramid. It's knowing what's at the apex of the pyramid, but it's also knowing that you shouldn't attempt to do it in one go. It is a multi-step process, and each step takes you closer. Do not attempt to leap over the steps. Go gradually up to the top. And it might be 10 years. Even Google is saying it's going to be, well, they're saying 5 years now before they get to the top of the pyramid. But for the rest of us, it's still 10 years off effectively. And a maturity matrix always has 5 steps, which is a totally arbitrary number, obviously, but it's quite useful to have some kind of arbitrary stages. And what I always say is that that level 1 is where most people are now, which is you want to do something, but you haven't started really doing anything yet. So if you're listening to this, you're at level 1 probably. You might be higher, but you're probably at level 1. Most people are at level 1. Level 2 is kind of, well, where do you go first? And where we suggest in the book that you go first is with really basic operational efficiency improvements. That's right sizing your systems, turning off things that are not properly in use and you don't really need. And the value of that, interestingly, that's where you tend to cut your carbon the most, is getting from level 1 to level 2. So although it seems like that's quite unambitious, just doing a right sizing exercise, it's actually quite often we find that people will cut their carbon emissions in half by doing that, which is the biggest win they ever achieve. So don't feel bad at getting from 1 to 2. It's a really good goal to be setting for yourself. And then 2 to 3 is about, so level 2 is fairly manual. Maybe you do a 6-month audit on your systems and you turn off stuff that you're not using, or you right size some of your systems. Level 3 is about automating level 2. So level 3 is, I would say, your classic cloud native level to get to. And it's where every enterprise should head for. It's auto scaling, it's multi-tenancy, it's GitOps, it's automating all that right sizing that you did in level 2. And then level 3 is suddenly starting to think about moving workloads to when the sun is shining or the wind is blowing. So encapsulating your workloads. So spot instances are quite a good thing to be thinking about there as a technique. But also using platforms that are written in C or Rust that are really efficient. And then level 5 is that really kind of really tightening up on that and making the code super efficient, taking it from maybe written in Rust or written in assembly language. Level 4 and level 5 are never going to be achievable by the ordinary enterprise, but they are achievable by the folk who should be producing your platform. They are achievable, and they should be achievable by AWS, Azure, Google Cloud, and we need to hold their feet to the fire and make sure that they do it. They don't just talk about it; they actually do it. So enterprises up to level 3, it's really good quality cloud native behavior, and then adopt the platforms that will take you up the rest of the way, that will do the code efficiency for you. Because you never want to be back in the 90s like me.
Well, I mean, I would argue that the 90s were a simpler time. When we talk about this journey, irrespective of the levels, and I'm sure there are metrics to talk to at each level, are there any signs or success factors that you would probably define when it comes to um, each level? How does an organization really know if they have succeeded? Like, obviously, for you mentioned that at the very first level, it's just mostly people who know that something's wrong, they want to do something about it, but they're not really doing anything about it. But then between level 1 and level 2, how do you know you go to the next level? What is the success factor for moving from one level to another? Like, I know that it'll be different for each of those levels. I'm not expecting like a listing, but an overall idea, if you can provide that, it would be great for our audience.
So level 1 to level 2, I'm a big fan of using proxy measures, because actually, oddly enough, getting the actual literal amount of carbon you're causing to go into the atmosphere, it has such a lot of different conflicting information in that number that it can be quite difficult for you to then act on it. So you're looking for something which is kind of like for likable, so you can track your progress. Level 1 to level 2, I tend to recommend that people use their their hosting bill. Maybe that's an electricity bill if you're on-prem, or your hosting bill if you're in the cloud. Now, you have to be mindful. You can't just blindly use it. You have to say, because if someone goes along and says, I've just managed to negotiate a 50% discount, that's 50% less carbon. It obviously isn't. It's like,
Yeah.
if you're on a like for like, then you cut your hosting bill in half, then electricity is a big part of what your host is spending their money on. So it is worth looking at that. That is not a bad proxy measurement for 1 to 2. For when you get to 3, what is the proxy measurement is an interesting one. You could use hosting bill again. I don't think that's crazy. You can use hosting bill. But you might also want to use some crazy other you might also, in many ways, you could be starting to measure how good you are at being cloud native, for example, as your proxy measurement for level 3, which might be something like release frequency. Because that's not a crazy proxy measurement for how good you are at cloud native. So at each stage, it is perfectly reasonable. And all the people I know who are successful kind of come up with their own proxy measure, and they go, do you know, that actually reflects what we're trying to do. We're trying to cut down the number of machines we have, so we'll actually have a machine count, or it all very much depends on what data you can get your hands on. Because that's going to vary a lot. If you're on-prem, you can get your hands on your electricity bills, but if you're in the cloud, good luck with that. You're never going to be able to do that. So it's don't feel bad about making up your own measure based on what you can get your hands on. And the Green Software Foundation say that as well. If you look at the SCI standard, it's actually kind of like, here are the kind of things that you might want to put in your made up measurements. And as long as you're consistent with it, it's totally fine. You know, it doesn't have to be perfect. You just have to be able to say, this month or this week, am I better or worse than last month or last week? And as I was saying, sometimes a proxy is much better for that. I know loads of companies who've given up using actual carbon because they realized that things like, was it sunny or windy last week, was mixing up with it's very hard to iterate on your development practice based on whether it was sunny or windy last week. It's too noisy. A literal measurement can be too noisy.
Yeah, and given that we spoke about metrics and also about the matrix or the matrix rather, what are some of the challenges, despite all the educational material that you have out there, including your book and including all the material that the Green Software Foundation has, all of that, what do you think are some of the challenges that or experience the challenges that organizations face in this journey as of today? Because yes, access to the correct kind of information is one challenge, but what are some of the other challenges that you observe when people are a part of this journey?
Well, I'm going to be very controversial here, and you'd get complaints about this. I'm going to say that green campaigners can sometimes be the worst challenge because, well-meaningly, folk do have a tendency to say to put binary choices in front of businesses, like, well, you can either rewrite your systems in Rust or you won't be green. And that isn't the case. There are so many different things that you can. And companies go, well, I would go out of business if I rewrote my systems in Rust, though I won't do anything at all. Which was the entire reason for doing the maturity matrix, to say no. There are the bigger wins than rewriting your systems in Rust are really easy things for your business to do, like just do a thriftathon where you go through and say, do you know, could we reduce our hosting bill? It's things that are much easier for your business to swallow. So the other things that I hear people saying, oh no, don't say that. Don't make customers choose. Don't make your business force your business to make that false choice. Is AI? Well, if we do AI, no, we can't be green. That's it. And then the company goes, well, we have to do AI because that's the way the business, so we can't be green. So they just go, well, let's cancel all the green projects and that's not the case. There are ways that you could do everything, which is why the book, we try and concentrate on the principles. There are ways you can do everything in a green way or a not green way. You don't have to give up AI. You don't have to throw away you don't have to stop retaining data. That's another thing that's like we can't save any data because data is really bad. And it could cause a load and everybody's going, yeah, but we might want that data later for AI, so we're not going to do anything at all. The reality is there's loads of things you could do. You could move a whole load of data that you currently have on a retrieval SLA, which is too high. Things like, actually, we want to be able to get this data within a millisecond. If you're prepared to just get that data within a day rather than a millisecond, it could be on tape. And tape is a very carbon efficient way of storing data. And it's perfectly reasonable for AI. The AI will wait a day for you to get that data, because you'd have to do a whole load of cleaning up of the data anyway. So fundamentally, you can make decisions like, can I reduce the SLA associated with this? Can I put data on tape rather than have it be instantly accessible? That would be massively greener, but it wouldn't be against every other business interest within your company. There's an awful lot of trying to, let's not ask for the moon when we've got the stars. It's kind of like, you don't ask for too much. Don't make a company choose between being green and succeeding as a business, because you will lose, and it's not necessary. Sorry, that was my soapbox
No,
there.
fine. And I was about to ask you a question on AI, which you probably already answered with this. So I mean, you killed two birds with one stone, I guess. So I was going to talk about how what are some of the challenges that you see when it comes to the new introduction of AI and ML and all the stats around electricity consumption and GPUs and stuff that are thrown out every single day, that you read the newspaper, you see all of that. But you covered that by with your
Oh,
previous answer. Yeah.
I have even more to say. I could talk to you forever about that subject. So I think that there's an enormous amount of learning that can be done by looking at DeepSeek on this. Um, there's lots of stats at the moment saying, if AI continues as it is, then effectively it's going to use the entire grid and we'll all die because we know electricity left for anything else, and therefore that's what's going to happen. The reality is, if something can't continue, it will stop. And an amazing example of that is DeepSeek. So you've probably heard of DeepSeek, the Chinese competitor to OpenAI, that popped up, a couple of months ago and said, well, actually, we've realized we can do AI with a tenth. We can do comparative AI. Actually, if you talk to them, it's quite similar to ChatGPT, and we can do that with a tenth the power. And they used a combination of moves that are part of the maturity matrix for green software. They reduced over provisioning by reducing the number of decimal points they were calculating to. Totally arbitrary 32-bit when they only needed 8-bit. That will have saved them a whole load of CPU and power. And they also started to adopt something I would say was a bit more of a microservice model. So they call it mixture of experts. They say, well, this part of the model is good for answering this kind of question, and this part of the model is good for answering this other kind of question. Rather than running the model like a monolith, we'll run it in bits, more like a microservices system. That's probably saved them a bit as well. And then I'll say that's similar to level 3 of the maturity matrix. And they've also done something which is similar to level 4 of the maturity matrix, which is that they've replaced the quite inefficient and very layer of isolation, the platform above the NVIDIA chips. They've replaced that with a much more efficient platform, and that's saved them a load of power as well. So it's a really good example of AI can be massively made more efficient if you want it to be, if you need it to be. China had to, because of the Joe Biden restriction on chips, which forced change, forced improvement. When improvement is forced, it happens. We can be more efficient if we have to be.
Yeah, and I think with that, I would want to ask about some of the things that you personally are excited about in this space. Any framework or tech or advancement? We spoke about the maturity matrix, and we spoke about some of the work that is being done in the AI ecosystem very briefly, but are there any advancements, any frameworks that you're particularly excited about in the green software space?
Oh, that's a very good. That's an interesting question. What's what? I actually I'm going to come back to it. It's not new. It's been around for a long time, but it's my constant obsession. I love this concept, and I think it will. I think this really encapsulates where we're going to be in the future. Spot instances. They were actually they were another thing that really kicked me off down the green route. So a spot instance at the moment is if people aren't familiar with they're available on AWS and Azure and Google, and they are a way of saying, look, I have a job. It's not particularly time sensitive. Um, Give it to a hyperscaler and say, just run this whenever. Effectively, they're saying, it's not, but fundamentally, you're saying, I don't really care when it runs, and I'll act on the results when it comes back. And as a result, it's a tenth the price of running something where you say, you have to run this now, no matter what. And it requires you to work out what tasks you've got that could be encapsulated that way and run in a time insensitive fashion. So it's a good chance for you to step back and think about things that don't need to be run urgently. At the moment, spot instances are mostly used to improve the operational efficiency of the clouds. It's like, oh, there's a bit of space here on a machine. Let's run something quickly here. There's a bit of space. And that's good. That reduces the number of machines required to run a system, which is great. But what I like about them is that because they are a tool that encourages you to think about how your system can become less time sensitive, they will in the future really help with delaying things until the wind is blowing or the sun is shining. So I really like the tool. It's not a new tool. It's been around for ages, but I think it's the right mindset to be getting into. And everybody who does a little bit more with Spot Instance will be absolutely living the green software dream, as far as I'm concerned.
And how do you see it evolving? Of course, you mentioned spot instances being becoming more ubiquitous, probably in your previous answer. But do you see this space evolving into something massively different over the next decade or 30 years? Surely, I mean, it's gonna have a massive transformation, because 30 years before it was something widely different. Now it is something widely different based on the constraints that we are facing. How do you think it's going to evolve in the next decade or in the next 30 years? You can
Yeah.
choose the time frame, I guess.
Over the next decade and 30 years, I'm already seeing some really interesting things happen in some places, but not others. The places where I'm starting to see things that I think are going to reflect where we're going to be in 10, 20, 30 years' time are a strange mix: Texas, India, and China. So they're all as areas, as regions, they all have an energy strategy, which I think is interesting for us. So in many ways, the one I like the best is India. So India has started to make noises about the fact that they want to produce time of use tariffs across India that reflect the fact that power is much cheaper at times when the sun's shining and much less cheap when it isn't. And I think they're suggesting that individual areas of the grid start to introduce a 10x difference, even higher, between when there's power available, when there's solar power available, and when there isn't. And then you're going to use that to drive industrial behavior and domestic behavior within India. And I love to see that, because without incentives, you aren't going to drive that change. And people are very good at handling that kind of thing if they're given the incentives to do so. So India is doing that. It's fantastic. China have a really interesting policy, which they're calling East Data, West Computing, where they say, well, actually, the data is all produced by humans, and they live in the big cities on the East Coast. But actually, we don't want to be doing our data set. We don't want our data centers to be there competing for electricity with the folk who are living in the cities. We want our data centers all in the West, where there's loads of space to do solar and wind. There's loads of capacity that you can build nuclear. So they're kind of making the decision. They're making the choice. Let's separate out these industries that require a lot of renewable power from people, because all these industries require space. You don't want to be having them competing with urban populations. And Texas is doing some very interesting stuff as well. They're kind of recognizing the fact, the Texan grid is recognizing the fact that they really want people to start adopting that spot instance mentality. They're saying they're looking for large, flexible loads that use a lot of power but aren't that time sensitive. So I think those three are really showing the direction that the world will inevitably travel.
That's cool, actually. I've heard about all of these instances, but haven't read up much in it. But it's great to see and hear about these specific examples, because I've heard of companies from the UK leveraging like the water waste. I mean, I think the heat generated from the power to heat up water in the swimming pools and stuff like that. So I've heard of those instances, but not of the one specifically that you mentioned. So it's actually pretty cool to hear that more and more people are thinking about sustainable ways of building the technological frameworks as we go ahead. And last, I think, before we end the session, because I realize we're, I think, 10 minutes ahead of, I mean, overtime. Uh, what what are some of the resources and communities that you would recommend for people who are on level one right now? Because most of us are, like you mentioned and correctly ascertained. Um, so, what are some of the resources and communities that people can get involved in?
Well, obviously, I would say read Building Green Software from O'Reilly. That is the first place to start. And it's a quite nice, easy read. It's not particularly technical. It's kind of like focusing on the ideas and the concepts. And you could listen to the Environment Variables podcast from the Green Software Foundation, which I'm quite often a guest host on. So that's a very good podcast. And there's also the Green IO podcast, which is again a good one to be listening to. So those are all good places to start getting your head around this. But if you are in Cloud Native and you're interested in that, you could also read the Cloud Native Attitude, which is my other book, which does have a sustainability chapter in it. So there's lots of podcasts, lots of communities. Go for it.
Yeah. I'll link to some of these resources after getting in touch with you and after the show, so that people can directly reference them from the description section of the live stream, and they're able to access it more easily. But like I said, we are nearly 18 minutes ahead. It was not even 10. It is 18 minutes over time. So I'm not going to keep you longer, because I know that you probably have other commitments. But thank you so much for joining us today. It was wonderful having you here and wonderful talking about all the work that you've been doing in this space. So thank you so much. That's all I got to say.
Well, thank you so much. I've really enjoyed it. It was lovely to meet you.
It was lovely to meet you as well. And I'm sorry to our viewers, but we'll not be able to get to our questions today, since we ran quite a bit over time. But if you do have any questions for our guest today, She is very active on LinkedIn, and with this, I think I'm going to send quite a lot of folks your way. And I'm sorry about
Yeah.
that, but very active on LinkedIn, and she is frequently, talking about the stuff that we just spoke about in this live stream. So please feel free to reach out to her, and I'm sure she's going to be a gracious audience to your questions. Thank you so much once more, and I hope everyone has a lovely day.
Thank you. Cheerio. Bye.
Thank